Good morning from Texas and the Pacific Northwest. We are here being joined by Prasad Yalamanchi from Lead Semantics, and we're going to be talking about a really great geeky tech subject that I'm super excited about, knowledge graphs. Prasad, maybe introduce yourself real quick and tell us why it is that we're talking to you about knowledge graphs.
Thank you, Stefan. I'm delighted to join with you too on this discussion here. So I am Prasad Yalamanchi, as you introduced. So my background is in knowledge and language systems. I have a couple of decades of knowledge representation and computational linguistics and big system development and things like that in the corporate. And over the course of last couple of decades, I have been involved in big system development for telecom and various other domains and such. But over the last 7 or 8 years, it's been focused on language and machine learning and those systems. And especially in the 4 to 5 year time frame, we started developing our own product in our company, Lead Semantics. And the product itself is taking in unstructured data and converting it into knowledge graphs, and that's how knowledge graphs would become the focus. And why knowledge graphs and why knowledge at all in the first place will be of interest throughout this discussion, I'm pretty sure. And that's what hopefully we'll have a chance to kind of unravel it, if you will.
Unstructured data and knowledge graphs. I'm excited already about this topic. I'm super interested. Pascale, why is it that we're bringing Prasad on this broadcast? Because we have some great news for all the listeners as well. Is that correct?
Yeah, we're very excited to have Prasad today on this podcast interview. However, what's more exciting for our audience is we're going to have 2 sessions with Prasad offered at the LangOps Institute. So we're going to have a 1-hour session, which is going to be aimed at the general public. And this is to better understand knowledge graphs in context of an organization, and really get more better acquainted with the concept of knowledge graph and why they are critical in an advanced digital ecosystem. And for those that are a little bit more technically inclined, we will be having a 3-hour session with Prasad, and he will take a deeper dive into how to set up the technology, what are ontologies, and what is the relationship with our language community, and how do we bridge the gap between linear translation systems to now a multimodal system. So even I'm still getting familiar with the terminology. This is brand new, and I'm really excited to hear more from Prasad this morning.
It's really awesome, Prasad. I have to tell you, I wrote my first article about knowledge graphs maybe a year ago in my AI and Look newsletter, and there's a lot of talk about it. Very rarely have we had the chance to have somebody teach it to us and give us so much insight as you are going to do for the LangOps Institute. So I'm really looking forward to that, and I want to kick off putting your feet a little bit to the fire here this morning. In an age where everyone is talking about generative AI, why should businesses care about knowledge graphs?
Right. It's a pretty timely question, and the times generative AI, as rightly said, as everyone would rightly say, is the rage of the time. Clearly, over the course of last 3 years, for sure. And generative AI, rightfully so. I mean, it has captured the imagination of the common person, and so all the limelight is accordingly has shifted to generative AI. If you break down what generative AI does, it is actually generating content based on the patterns it detects in the input that you give it, and the patterns that it has found to be statistically significant by getting exposed to all the pre-training, language, if you will, from the internet and what have you. And so all the patterns are processed, and then now they turn into weights, and then these weights have resulted in the predictions that you see. And so you have this free, flowing content that is getting generated, and it's very exciting to see. It seems like a person is really writing it all out. But when you look at it closely, and people have realized it, and it's been written about, and now it's prevalent in understanding of general public, that these systems produce hallucinating, actually confabulations of outputs, which is it's making up stuff. And it's still free form, free flowing and well formed, and it, for a unwary eye, it would appear to be pretty consistent, But if you start looking at it, it could be pretty wacky, if you will. I mean, it may not be factual even. And so, in situations and most of the business circumstances, that will not fly. You definitely want something that you can automate and process these outputs to your downstream applications, and that is where knowledge graphs and knowledge systems will come into play. Knowledge, by definition, is something that is relevant to the context. So for example, when we are talking to each other, we are understanding what I say, you are understanding what you say, I am understanding, because there is a common set of expectations that are met in the language that we transmit. And these things are very specific to the context now. In a different context, the same three of us, our language would be different. We would be talking something else.
Yeah.
And so yeah. Pascale.
Sorry to interrupt, but so before you get into even more detail, I want to make sure that I understand it correctly so our audience can understand it correctly as well. So dabbling into generative AI and the tools currently, what I see is that, yes, when I use generative AI, the content, the output is great. And it's like you have that first layer, the framework of the language is great, and then it talks about what you actually ask in your prompt. But when you spend a little bit more time, it's like the depth and the context is not quite there. It's just words that sound like it. So if I'm hearing correctly, what knowledge graphs is doing, it's going to bring the depth into the context and into the content that is being generated. So it's going to be a lot more, not only a lot more accurate, but it also will bring a lot more meaning to what we read. Is that a fair assumption?
Absolutely. And in fact, what you rightly pointed out is the heart of the missing thing in generative AI, and it is and it is prevalent right now that it is the feature of generative AI is what is producing all these confabulations, if you will. So it is nothing wrong with the architecture. The architecture is the one that is is able to cover all of the possible patterns that it is humanly impossible for an individual to have access to all those possible patterns to be available to the generation that it shows you. But the generated thing may not be accurately consistent with the situation into which this generation is happening. And that exactly dovetails into what you just said, which is, your expectation, the meaning that you're looking for may not be there. And that is what knowledge graphs will bring to table, because knowledge graphs are domain specific. So you create a knowledge graph specific to the domain, incorporating all the contextual information that is relevant, that is going to be important. And so that is into which, if a generated predictions come in, you evaluate according to what is expected through the filter of the knowledge graph. And that is what will, guide. A knowledge graph plays the role of a guardrail in terms of what it produces. So whenever it doesn't fit the knowledge graph or the schematic of a knowledge graph, it'll throw up, it doesn't take up that prediction, and so it'll allow the generative AI to kind of produce another prediction.
Yeah.
Until it fits the knowledge graph, and so yeah.
Could you maybe explain in layman's terms for people that are not familiar with knowledge graphs and the way they technically are executed? Is there a way that you can explain it a little bit to our audience so it makes sense as to how you get to be making knowledge graphs?
Yes, that's a fundamental question. Knowledge graphs, which is graphs of knowledge, knowledge by definition is like connected entities. Entities are like the real world things that we are familiar with, like people, places, things, events. These are all real world things that are factual things that you can anchor your meaning, your discourse around. And so all of those things interconnected are the knowledge graphs. So in any narrative, there are, for example, a newspaper article or a book, so there are factual elements that you can unambiguously say, we don't need any interpretation to say, okay, Donald Trump is Donald Trump, and things like that, all the facts. Similarly, like events and places and times and what have you. Once you capture all of these things, how are they related? And the relationships that are manifested based on the narrative of the article. So the same two entities, like person A, or like London city, and like some person may be related differently in a different narrative. So maybe one time you're flying through, and maybe another time you're attending a meeting in London, things like that. So based on the narrative, the same two physical entities are related differently. And the narrative kind of, highlights that relationship. And so if you want to capture the knowledge that is transmitted in an article or an unstructured, flow of information, so you are picking out all these factual elements and anchoring all the relationships, or overlaying relationships, and now that becomes your schematic of what is being transmitted in that narrative.
Yeah.
Yeah,
So
and I
many,
think
so many of our audiences members are linguists, so to speak, and so I was wondering whether knowledge graphs are language agnostic too. Does that mean that you can implement the technology across languages?
Absolutely. Knowledge is independent of language. Knowledge is, precursor to language, if you will. Language is necessary to communicate knowledge. And the same knowledge can be communicated in different languages.
Mhm. And I think here I'd like to make an analogy. So what we've seen over the last 30 years, we've started to break down content into segments, and we've had translation memory. And the way we present it within our Discover LangOps, for example, we look at, okay, so this is the content, this is the tip of the iceberg that we see. We see the content, it's tangible. But as we're moving into this advanced digital ecosystem, the content is fragmenting, and now an organization has so many systems and application that this content has become fragments. And now as we move even further into data, these fragments are becoming data points and knowledge data points. And so what used to be a translation memory, now we're going to work with a knowledge graph where all the knowledge is there and mapped to certain units, but then we still need a framework to generate to go and work with the right knowledge type, or to make the connection so that we get what we want. So it's kind of like the future of our I'm not going to say TMS, but it's the future of how to frame and ground the content that will be used for a multimodal output. Is that a correct analogy?
Absolutely. I mean, and just to highlight some of the things that you said, is the content is the source that you want to, with high fidelity, be transmitted in different languages, right? That would be the goal of the exercises here involved here. And so this content is now, if it is in the form of like these TMS segments, and these segments have data elements that are representing the knowledge of the content. So always the intent is to make sure the knowledge of the content is transmitted with high fidelity. And so now if we have the knowledge graphs, as I described, the essential aspects of the original content in the form of a knowledge graph, and then the aspects of the TMS segments as knowledge nuggets, and they all have links back into these knowledge graphs, you have the full scope of the context. The 360-degree context is available at any point within these TMS segments. And so with the context being available, the human processes or even downstream generative AI processes have the full breadth of all information when you look at even the piecemeal of any given TMS system. And that has an effect of producing much better translation or localization.
Yeah. So we're moving left. I mean, we're moving really, really left into how the brain is working and knowledge and everything. But how fast can we scale a knowledge graph? Where are we right now? Because there's the hype, there's the talk. I personally know people who are implementing that within their organization, but it's baby steps. So how far are we from scalability and adoption?
Very good question. Very good question. So there is a transition line prior to which knowledge graphs were, have been esoteric and very technically demanding, and certain, it's an arcane thing. Only certain academic type of people were kind of talking about, what is involved in knowledge graphs. But that has clearly gone away. The technology is a lot more accessible. I mean, it's more accessible. It's just a matter of just killing the people, saying that all these things are available. And it used to be very expensive, and now it is like no more. And the scalability it's still involved, but the scalability issues are almost not there anymore. We can scale to so-called, these nodes and edges that form the knowledge graphs. They can scale to hundreds of billions of, nodes, in a routine processing pipelines. So you have, let's say, a corpus of text, let's say, of 10,000 pages of documents, and you can literally produce the equivalent of a knowledge graph in a very short order in a knowledge graph, and then and you can draw the entire content, have links to the nodes and edges within the knowledge graph that gives you highly tractable way to get your answers anchored in the text with a snap of a finger. For any question that you ask now, it goes through the knowledge graph, and then and the question, the answer that is produced to this question is anchored in some page somewhere, or some paragraphs in this 10,000 page corpus, and it highlights those things instantly. So scalability is no longer the issue.
Yeah. And what about mapping? Sorry, Stefan, mapping. So how challenging is the content relationship and mapping to do? Because it has to be done by the human, right?
Exactly. And there is a very methodical way to go about this. So as we said, and this is where the knowledge graphs aside, knowledge graphs is the technical artifact. The knowledge itself of an organization is there among the enterprise. Now, if you codify that, and that the equivalent of how you get there is by creating an ontology of an enterprise. Ontology is a bigger word, but if you break it down, it is like just schemas that everybody is familiar with in various technology, tooling that they may be associated with. And these schemas are a little more involved when it comes to knowledge. And so if you have an organizational schema or an ontology in place, then all the knowledge that is generated is one way or another captured by is anchored in this ontology, and so they are all meaningfully connected to each other.
Before we're way deep into the nodes and edges, maybe we can come back one step and give some examples. I'd be interested because we've been talking about this technology for a while now, and we know that companies like Google and Amazon or Netflix, the really big ones, they're using this technology on a regular basis. But could you, as somebody that's involved with knowledge graphs on a daily basis, maybe give us some real world examples of how knowledge graphs are creating practical value in an unexpected way in different industries. And if you could tie it to localization or LangOps, even better. But we're eager to kind of see and share some examples with our audience.
Yeah, I will relate to since you asked. Google, of course, it has this knowledge graph from maybe 2010 or 2012, one of the earliest large-scale knowledge graphs that is producing a lot of value to mainstream application, which is the search, as you will. And similarly, Amazon product knowledge graphs are pretty extensive. As you would know, Amazon has this extensive, huge, catalog of products, and their relationships and all of that is kind of mediated through these product graphs. And similarly, LinkedIn. We are all on LinkedIn every day, and all these connections and all of that. There is a big knowledge graph that is making it all sensible, and all that is. So you will see the value at that scale is being literally made possible through knowledge graphs. And personally, one of the newer things, and I don't know that other people have not gotten into it yet. Like, for example, content search in media circumstances. Media is exploding in terms of content creation. Every citizen is a creator now. You need not be an artist, unlike, skilled and qualified person of some sort. Now with the AI tooling that is available so readily, content is exploding, and so any typical organization has like these, million, artifacts just explode, just millions of artifacts in a sizable organization. Like, you have all these video clips, you have images, you have audio, you have text, and all of that. And yet, when it comes to either creating new content or like trying to do some programming in media houses, for example, they are trying to look for existing clips or existing content, so that they can build off of it, so that it can reduce costs and maybe build a consistency, and all of that has already been taken care of early on. Maybe it is something related to Ukraine and Russia war, right? For a TV house, for example, and they are looking through their media corpus, and so that's where these knowledge graphs are playing significant role. That is a new age application kind of a thing. So this content search, you can look for maybe Shahid drones flying over Kiev, for example, and you are looking for something like that. And it is not necessarily the metadata. You're not stopping at searching with metadata. You are actually interpreting the content within the clips of the video, within the imagery that is held into the footage that is stored, the literature or the articles that some journalists may have written. You're sifting through all of that and then producing what bits and pieces, some video clips, some footage somewhere, and some text somewhere. All of those are popped up as candidates to your question in natural language. That is made possible through knowledge graph in the middle.
Yeah. But in the language industry, we've been used to this kind of one-to-one transfer of content in one language to content in another language. We work with translation memories, or have been working with translation memories for decades now, and that essentially at its base core is the transfer from one text string in one language to another text string in another language. The data always had to be structured. With what you're explaining to us here now, it seems to me that those memories probably are becoming quasi obsolete, because you don't need to have the data structured quite as much anymore. You can actually submit your whole corpus of content and in different languages, and let the AI figure out what the correlations are through implementation of language graphs, of knowledge graphs. Is that correct?
Yeah, a slight variation on what you just said. The translation memories will still, in my mind, will exist. Only thing is, translation memories will evolve into knowledge graphs, because that and knowledge graphs are guided by ontologies, and ontologies are language agnostic.
Yeah.
As I said, this is the organizing, principle of knowledge, and its knowledge is independent of language, and so the content is held and organized in an ontology, which will
Mhm.
reflect in knowledge graphs of various languages. And
Yeah.
so the mediation of search and all of that across your content in various languages is no brainer anymore, because it's all mediated through the ontologies.
And I think I'd like to add here for the audience is that the way we're advising our practitioners in LangOps, especially in thinking ahead to get set up for knowledge graphs in the future. The focus now is, okay, you need to get square one right, because you need to start building a content structure that is going to be useful in mapping the relationship of that content. So yes, we will not need to have the data structured the same way as we had it in a translation memory. However, I think what is even more critical now is to properly understand the relationship of the content within an organization so that you can build the ontology and really understand how these different ontologies, whether you're in HR and operation, and how these two could interact, and then how it would impact, excuse me, employees if they're doing the chatbot or things like that. So we still need to structure the thinking and the relationship, but it has to move left because we're getting even more deep into the concept and how we're creating content. Is that
Yeah,
fair?
yeah, absolutely. So the ontology of an organization is really holding on to the essential elements that are part of the mission and charter of the organization. And so once you have that in one place, all others, be it HR, as you said, maybe finance, maybe operations, and maybe sales and marketing, they all fit ultimately. They are all playing to the mission and charter of the organization at the top. And so the language they use to get through their day should all be consistent with the mission and charter of the organization. And so if you look at it that way, through an ontology, it is very easy to integrate. Now, the terms that will encapsulate or kind of project that meaning of the organization is consistent across these otherwise silos today. And once you introduce these ontologies, it is so much more easy to integrate across these departmental, any productions.
That's how we break silos. We map
Yep.
and connect them together at a very abstract level that we are
Right.
bringing in a more concrete way.
Right. Right. Absolutely.
I have a geeky question that I quickly want to ask because you're sparking my brain here, and it's the kind of question that I can't ask a lot of people. How does retrieval augmented generation RAG tie in with knowledge graphs? Can you tip the veil on
Yeah.
that a little bit so we can connect those dots?
Sure. So I will take a step back and maybe connect to one of your earlier questions, which is in the times of this highly popularized times of generative AI, what is the role of anything like knowledge graphs? Or RAG is precursor to knowledge graphs is RAG system. What was even the need for a RAG system, for example, when generative AI was supposed to do everything? It's because the domain specificity is missing in because this foundational generative AI is foundational. In that sense, it's highly generic. It is trained on generic patterns, extracting generic patterns across devoid of context, right? It's just across all the humanity. And so it doesn't know the special situation into which it is predicting and making these predictions. And so your RAG system is supposed to kind of give you that layer of your specific content. So you are fine tuning it well at runtime pretty much to the content of that suits your context. And RAG itself is like continuous corpus, and it still produces better results, but it doesn't. There's still more room to cover, if you will. And that's where now, graphs come in. So the so-called graph RAG systems have come in. Because the relationships between the content elements hold such significant pathways to, guide meaning and meaningful, extraction of relevant answers to your questions. Is you cannot have it in plain RAG. You need, connected graph elements. The comprehensiveness of the coverage of the content comes from these relationships. And so graph RAG has come in. So now we have RAG and graph RAG to add to the plain generative AI, right? And so now graph RAG is one type of RAG, and a specialized graph RAG would be knowledge graph RAG.
So there's all flavors. Yeah. One
Right.
thing that came to mind just talking about this right now for me is it sounds super interesting. What if I want to get started on implementing or designing a knowledge graph for the content that I have in my organization? What's the first step? How do I go about that?
So there are decent amount of tools that are available, and I don't want to make it a pitch about my company, but my company
Well, you should.
does that.
You should pull that in because we're most interested in how it works, and you probably know best how it works at your company. So go ahead.
Absolutely. So I'm thrilled to kind of talk about we have a product called Text Distill that we have created almost 4 years ago when the first BERT system came into existence. Text Distill takes in unstructured data, as I said, like text, gobs of text, like just millions of documents of text on one end, and then it just pumps through this pipeline and produces a highly structured knowledge graph on the other side. And in order to produce the meaningful knowledge graph on the other side, we need to configure Text Distill with an ontology that fits the domain of the corpus of the unstructured data that you are dealing with. So to your example, if you have some bunch of documents that you need to produce a knowledge graph out of, I would like to know what domain it belongs to and start with a rudimentary a root core ontology, if you will. It's very simple to start with. It may be different people, whatever the essential concepts that are being treated, are being discussed, are being narrated about in your corpus. Start with those, and you add more relationships, that are manifesting in that narration, and then use that as a configuration.
Who creates that ontology? Is that you do that in conjunction with your customer creating the ontology?
With the customer, and actually that is another session within Text Distill itself. We take some representative corpus. If you have probably your goal is to translate 100,000 documents into an equivalent knowledge graph, and maybe there are about 1,000 articles or 1,000 pages of text that is representative of these 100-page hundreds of thousands of documents. That representative documents we run through Text Distill, and produce all these concepts and interrelationships automatically, and use that as your default bootstrapping ontology, if you will, and then use that to extract knowledge out of all these big corpus. And then if it doesn't, it's not suiting the thing, you iterate one more time. So it's an iterative process, but it's completely automated. And the net is that you get your completely structured, highly structured knowledge graph on the other side, which you can directly ask questions, and you do your graph RAG, if you will, using that knowledge graph.
Now, I'm a big dreamer, and you immediately spark my imagination. We start talking about how to implement that knowledge graph in my organization. And then I start thinking about what the implications could be of designing that thing. And so I wanted to bounce this idea off of you and have you tell me how close I am to reality, maybe put my both feet back on the ground if I'm too far off. But let's say I have a huge corpus of content, maybe a company that stretches over several continents in 10 languages, that operates in 10 languages, and I dream of having a chat bot that I could prevent from having huge hallucinations, and I wanted to stay within certain guardrails of what we talk about within the company. Would a knowledge graph implementation be a great way of putting that thing in place without having to worry too much about it going off the rails? Is that what I'm understanding correctly?
Right. I mean, you will still have to worry about it because knowledge graph creation, that ontology creation will be incremental. Because in the first go itself, you will not be able to cover all the possible ways that various concepts and elements of even your own business are being treated in the corpus that you have. And so it will be an iterative process. But this would be an ideal tooling, if you will. Your generative AI and knowledge graphs together are the pillars that will kind of play the end game for you
Mhm.
through iterations.
Yeah. What are the
And
biggest? Go ahead, Pascal.
do you need besides partnering with a semantic company, do you need a specific technology internally in your organization to manage that, or how does that work to implement?
Yeah. So once you have identified the corpus that you would like to kind of turn it into a knowledge graph because you have seen the value of knowledge graph, you want to try it out, right? The first skills that are required would be to be able to guide, to develop an ontology of sorts. You need not be rigorous about it. You don't need to learn the philosophy, the full skilling of an ontology, but some elements of what makes up the ontology, which are the concepts, the entities of the corpus, and the interrelationships that are significant, and to be able to identify that. It's a little bit of a skilling that you will have to go through. And once you have that, I think all the rest of the tooling is in place. And then you will be able to evaluate whether an ontology you know, is meeting your requirement to
Mhm.
produce a knowledge graph that is useful for your downstream applications. And you will be able to see that by asking questions of the generated knowledge graph.
Okay.
What do I do
And
to get there? Do I hire a data specialist for that? Does Lead Semantics provide that service? How do you get started on creating the
And
ontology?
in all of our engagements, the companies themselves have the knowledge of their domain, and
Mhm.
so
right.
they continue to play a very significant role in guiding our engineers. And there is not a whole lot of back and forth. It's only there is a phase, and this is where, depending on the project that we have seen, um, there are highly business oriented corpuses, like media, and these are all, I mean, any other business, for example, or and then there is a spectrum of other types of corpuses which are very abstract, where the facts are few, but then there is a lot of abstract interpretation, and there is a lot of commentary that you cannot just write it off because the facts are only talking about a few things. You want to capture that abstract layer of meaning because meaning is transmitted in this abstract language. And so you would need the expertise of the content creators to kind of guide us, and the ontologies can capture all of that. It may be layered and it may be involved and all of that, but it has the potential and scope that it can handle.
And for those of us that have been in the industry for a very long time, we have captured the data into those translation memory database for 10 years, 15 years, 20 years in some cases. Can you transfer those TMs or translation memories? Can you use that data to populate your the knowledge graph? Is there a good path for that? And or I shouldn't say a good path, but what I meant is it how complex it is to go from a TM to a knowledge graph.
Right. I mean, absolutely. And we are actually doing that right now in some use cases. I may not be able to speak in detail at this point, but I mean, to your point is extremely relevant. So translation memories are absolutely the ground zero, of where knowledge graphs will have a footprint. And then they connect back to your source knowledge graph to give you that all around context being available at every step of the way through your entire translation process, all the way to your post processing, verification and confirmation.
Since
So
go ahead.
yeah.
Since we're so deep in the weeds, I'm going to ask you a question that I've been thinking about for a couple of years now, and you're going to be the ideal guy to answer this since we're talking about translation memories. One of the challenges that we've had for decades with large translation memories is that at times we work for customers that have different opinions about how things should get translated. And internally, we might have a translation memory for a specific customer, let's call it the gap. And the marketing department is translating a sentence a certain way. And in the legal department, they have a completely different idea about that. How does that really work, sucking those things
Yeah.
into knowledge graph methodology, so to speak?
Right.
I'm fascinated
So
by
this
it.
is this. I mean, I'm going to pick up your last word because I am fascinated by it. I was going to say that, and I'm glad you said it. The critical thing that it does is the linguist role will be highlighted that much more when we bring in the knowledge graphs. What knowledge graphs will get newly to this entire game is that they bring in the context at the time that you are verifying whether this particular translated output is accurate or not. And you have the context with the full context of what the translation memory, as you rightly said it. Now you have an opinion. There are two people that have seen the translation memory and said, okay, this may not be accurate or high fidelity of what I expect. And so now you have a third reference that is neutral, but it is contextually rich and it is objective, and that allows you to kind of gauge how far off your opinion is. So your quality metrics, qualitative metrics can be a little more data centric.
So
And
basically,
that way,
you should be reviewing a better output because you have more context, and then you were able to take into account the diverse viewpoints of the linguists. If I may say.
abs- yes, absolutely. I'm thrilled to kind of really see the language that you are using, and I'm kind of trying to
No, this is
come out
perfect.
with.
And Stefan, your example is perfect because, what we've been building in the back end. So when you have a complex ecosystem, you have several translation memories because you don't want to, the word we use is typically you don't want to pollute them because if you're doing marketing, it's not a literal translation, but then you go with legal and you go with operations, you need to have a legal point of view in a literal translation. But what I see and I'm hearing is with an ontology, that mapping can even more refine the actual output because you can take into consideration those variables, which in the past, you can't. Like you have to distill a little bit more. Translation memory, machine translation tries to do it, but sometimes the context is missing or the terminology is missing. So it seems like the knowledge graph and the ontologies, they're creating a synergy between all those variables.
Yes. And I'm not an expert like you are all in the translation domain, but I mean, I see that what you are speaking to is where knowledge graphs uniquely will fill that gap. And again, as I said, to have an ontology that fits the exact situation will take a couple of iterations, many iterations, if you will.
Oh, I think more than a couple.
Yes. But that is the tooling that is very
Right.
richly endowed in terms of rigorous experiences that have been around in the knowledge graph domain.
So I think the new buzzword in our industry, Stefan, is we're going to shift from TMs to ontologies, and then we'll create an acronym for that. I bet soon enough.
I've actually written an article about this very topic in my Look newsletter not too long ago about the possible extinction of translation memories. And another thing that I really would like to know from you, since you're the practical expert, and we so often talk about AI in a rather abstract way. Is there a practical way to get started without going all in? Is there a way that people can dip their toe in the water, so to speak? A lot of times, the impression we get is that you have to have millions to spend in order to get a project like this off the ground. What do you think, Prasad?
I mean, I would say, that's a misconception. Uh, Yesterday, I mean, past probably it was that way, but not anymore. I mean, you can literally take a 1,000-page corpus and start off trying to see, are you able to aim for its translation from your source language A to source language B, and introduce your, knowledge graphs vis-a-vis your translation memories, and see how the translations happen, your localizations happen. And I would like to add, after this point is made, a larger context why knowledge graphs are so indispensable at this point. Um, but to your point, I mean, organizations and teams can literally dabble into, this introducing knowledge graphs, get experience with knowledge graphs, get a taste of, what really can materialize with knowledge graph practically, very quickly with not a whole lot of expense, like, nothing
But
like those big numbers that you're talking about. Yeah.
yeah, thank you. But one thing that strikes me now as you're saying this is, so the way I understand it now is that organization are gonna have to have a knowledge management ontology or some sort of organizational layer that brings all that knowledge together so that you can maximize and optimize your output. Because if you do it in silo, it might not be the best approach, right? So I think from, like, if you're thinking big corporations that have very complex matrix, we're going to have to, or we're going to see the emergence of a much bigger knowledge management, which will have ontology, taxonomy, and like a lot more dedicated linguistic resources. Is that correct? Or
A slight modification. The beauty of the technologies involved in the knowledge graph area, especially knowledge graph, semantic knowledge graphs, is that all of what you said is true, except for one thing. You can literally start with one department, let's say HR, or let's say marketing. You can create a local ontology. You can create the ontology of the mission of the organization, of the charter, and all of the board level, so that you have a guiding north star, if you will, of everything that can go on in an enterprise. And you take one department or even a silo within a department, a small section of a team's output, make sure that this end to end is all proper, and then go on with your localization efforts and all that. And the knowledge graph technologies are such that you can evolve them to fit all the rest of the pieces in a very coherent and integrated way along the way, whenever it suits your either time and expense and whatever, and all of that.
so this is incremental changes.
Absolutely.
That
Incremental,
is
coherent, and organic way. Yeah.
absolutely.
We only have a couple of minutes left, believe it or not. That's how quickly this talk went. I'm going to be in your class in the first row. I promise you, Prasad. You have given us more value in an hour than I have listened to in a long, long time. I want to give you a parting question that can make us dream a little bit more. Looking ahead in the next 5 years, where do you see this technology going? And is there a correlation that you can make with the language industry? And maybe give us an example of something that we haven't even thought about that the technology could do in the future.
Absolutely, wonderful. I will bring into context the big raging discussion that is happening in the AI, which is everything, front and center, which is this the language models for the next round of evolution. The prediction is that the focus is shifting towards inference time computing, so called. in the pre-computing, pre-training, all of the data is kind of, fed in. All of the data there is in the world is already exhausted. And so the foundation models are already reflecting all of that, but in a generic way, and that was intentional. So these are, very generalized foundation models. On the other end, on the output side is the post-processing, where you are trying to kind of align the outputs of these foundational models to human, guidances, human expectations. And, the alignment is the so-called RLHF, they say, the reinforcement learning and human feedback is like trying to align to human expectations and human constraints and, things like that. So there is a post-processing phase where you are training or layering another fine-tuning layer specific to the outputs that are you're expecting into human situations. Now on top of that, there is a reasoning, inference time computing, and inference time training, if you will. These post-processing, if you imagine one step further, is literally narrowing it down to a specialized context. And that specialization is through specific domain-specific knowledge. Like, for example, reasoning, you cannot reason generally. You would have to reason specifically, either to a math domain or a physics domain or your enterprise domain. When it is domain-specific and you're trying to reason out, you need domain-specific training, and that is what knowledge graphs are all about. It is domain-specific data that is curated with human feedback already. So all of the post-processing has a big potential to kind of leverage the knowledge graphs, already, without spending and burning up half the earth and all of its resources in further training. Because no matter how much the training that you do, will never train it enough to reason for your enterprise.
Yeah.
So there is still that room of hallucination and things like that, and you still need to tie it down to your specific situation with your RAG and graph-RAG systems.
Yeah.
And so, so knowledge graphs have a fantastic role to play in the future.
I really want to trap you here for another couple of hours because I have a bunch more questions. But I guess I'm going to get another chance watching your class, and we look forward to that so very, very much. Pascale, I'm sure you agree with me.
Yes. Thank you so much, Prasad, for being here this morning. Truly appreciate the insights you're bringing in, and also how we can tie it to the transition that we're experiencing as an industry. So to me, it's a lot more clear to see how human is definitely at the core, because we're talking about concepts here and how we're going to orchestrate those concepts. But yet also we've floated the idea in the industry, we need content experts. And why do we need those? And so now you're also today.
Data labelers.
Yeah, the enablers, but the expertise, like that domain specific expertise, is so critical to how this technology is going to work. So now that we can actually talk about it with a little bit more knowledge, and I will say very small amount, but it's I think it's going to be valuable for our audience to see and hear how, yes, this is the knowledge graph technology, the expertise is needed because you need constant input and so on and so forth. So thank you so much. I really enjoyed that.
Absolutely. Thank you, and delighted to be part of this. Language and knowledge are two sides of the same coin. And so now, rightfully, to the language industry, we are bringing in the knowledge graph perspective or knowledge perspective.
Awesome.
Generative AI to get the most of generative AI, knowledge graphs are one of the best ways.
You're making our language hearts go pitter patter. Thank you so much, Prasad, for your contribution today, and we look forward to your course again very shortly.
Thank you.